Find the equation of the normal to the following curve at the point indicated by the given value of x. So here's the function, y is equal to x squared minus 3x. And we have to find the normal to this curve where x is equal to 2. First of all, we have to know what the normal is. We've been working with the tangent so far. And as we know, let's sketch an example of a curve. So this is going to be a coordinate system. We have the x-axis and the y-axis. Let's say we have this curve. It goes like this. And we want to find out the tangent in this point on the curve. The tangent will be something like this that goes through the point. The normal to the curve would be the line going through the point that is perpendicular to the tangent. So it would be this. This would be the normal. So the normal, this line, is going to be perpendicular to the tangent, which means that is 90 degrees here. This angle is 90 degrees. So we're going to find out the equation for this line, not this line, the tangent. Okay. We're going to begin as we do when we're going to find out the slope for the tangent, because there's a connection between the slope for the tangent and the slope for the normal. So let's just begin as we always do. Let's find out the y value where x is 2. So x is 2 and y is equal to, let x be 2. So it's 2 to the power 2 minus 3x. Sorry, x is 2, so 3 times 2 is equal to, this is 4 minus 6 is equal to minus 2. So the point P is going to be x2 and y minus 2. Now let's calculate the derivative for this function. Dy dx is going to be 2x minus 3. Now the derivative where x is equal to 2 is going to be 2 times x. It's going to be 2 times 2 minus 3. 4 minus 3 is equal to 1. So this means that m, or the slope for the tangent, is going to be 1. And this will help us a lot when we want to find out the slope of the normal. Because remember, the normal is just perpendicular to the tangent. So the connection between the two slopes is this. Let's say m is the slope of the tangent. Alright, within bracket, tangent. And let's call m index n is the slope for the normal. Okay, this is the connection. If we multiply the slope for the tangent with the slope for the normal, we're going to get minus 1 always. If we take any tangent and then the slope of any tangent and then the slope of its normal, we will always get minus 1. Minus 1 is minus 1, and we have m, so we can find out the slope for the normal. So let's just do like this. Slope for the normal is going to be minus 1, and then we move this over here, so it's going to be divided by m. Minus 1 is equal to, and m is 1, so this is going to be very easy. The answer is minus 1. So the slope of the normal is going to be minus 1. And then we just do, as we always do, to find out the c, or the y-intercept. So now we can write out the formula for the normal. Y is equal to m normal x plus c. We already know the slope is going to be minus 1, so y is equal to, we're not going to write minus 1 times x, we're just going to write minus x plus c. Now we would like to find out the value of c. Remember, we have the point on the curve, so we have an x and a y value. The point P was 2 minus 2. So the point P, 2 minus 2, will help us to find out the value of c. So x is going to be 2 and y is going to be minus 2. So let's see. Y is minus 2. I'm working with this equation. Is equal to minus, and x is going to be 2 plus c. Let's move over minus 2. It becomes plus 2. Minus 2 plus 2 is 0. It's equal to c. Okay, c is 0. So the answer to this exercise would be this equation. Y is equal to minus x. Since c is 0, we'll write nothing more. This is the equation. And this is how it looks like. We have the curve here. Y is equal to x squared minus 3x. And this is going to be the tangent in the point 2, 2. And here's the equation for the tangent. And the normal is the red line. It's going to be perpendicular to the tangent. And here is the equation of that normal, which is y is equal to minus x. And that was the answer we found out.